In last video, we have seen de Broglie equation and Heisenberg uncertainty principle. Now in this video, we are going to discuss the quantum numbers. A set of 4 quantum numbers which are required to specify the position and energy of the electron in an atom. And these quantum numbers are principal quantum number. It is denoted by small n. Azimuthal or angular or subsidiary quantum number denoted by small l. Magnetic quantum number small m. And spin quantum number, it is denoted by small s. These quantum numbers combine together to get complete address of an electron in an atom. So quantum numbers, it is a perfect address of electron in the atom. This is very important. So now first quantum number, that is the principal quantum number denoted by small n. This quantum number determines the main energy level, that is subshell, in which the electron is present. And normally this is the positive number. It gives idea about the main energy level. For example, suppose this is the nucleus, and around the nucleus electrons are revolving in a particular or specific shell, that is explained by Bohr's atomic theory. So this is the K shell. For K shell, value of principal quantum number is 1, n is equal to 1, and it is designated as K. Similarly, next shell, it is L shell. For L shell, n is equal to 2. Similarly, when n is equal to 3, then it is M shell. N is equal to 4, then N shell. So quantum numbers, principal quantum numbers may be n is equal to 1, 2, 3, 4, and respective designations are K, L, M, N. Now, the energy of an electron present in particular shell increases with increase in value of n. This is the formula for energy. En is equal to energy of any electron in a particular shell. It is given by this relation. It is equal to minus 2 pi square m e raised to 4 n square h square. So as the value of n increases, then this term, it will become less negative. Less negative means it will be more, it increases, and therefore with increase in value of principal quantum number, energy of that particular shell increases. This is very important. Now the maximum number of subshells allowed for a particular shell, it is equal to value of n. For example, for K shell, value of n is 1, number of subshells equal to 1. For L shell, value of n is 2, number of subshells are also 2. For M shell, value of n is 3, number of subshells are 3. And for N shell, value of n is 4, number of subshells are 4. Actually, it is considered that electrons present in shell there are subshells, in subshells there are orbitals, and actually electrons are present in orbitals. So in a particular shell there are subshells. It means in first shell there is only one subshell, in second shell there are 2 subshells, in third shell there are 3 subshells, and 4 and so on. In fourth shell there are 4 subshells, and so on. The maximum number of electrons allowed or permitted in a particular shell, it is equal to 2n square. For example, in first shell there are 2 electrons as per this formula, 2n square, value of n is 1, and therefore it is 2. For second shell, number of electrons will be 8, As per this formula, value of n will be 2. 2 square means 4, 2s are 8, and so on. In third shell there are 18 electrons, and in fourth shell there are 32 electrons. And number of electrons in given shell, it is given by 2n square. This is about the principal quantum number. Now next is azimuthal quantum number. Now this quantum number gives information about the subshell's shape of subshell or electronic cloud and orbital angular momentum. Now important thing is, for nth shell there are n number of subshells that already we discussed during principal quantum number. Meaning of this is, for a given subshell there are for a given shell there are n number of L values. Actually azimuthal quantum number, it is denoted by small l, and in a given shell there are n number of L values. It means there are n number of subshells. Again, the value of L ranges from 0 to n minus 1. 0 to n minus 1. For example, if value of n is equal to 1, that is the K shell. So number of subshells will be 0, and n is equal to 1. So 1 minus 1, that is 0. So only L value possible in first shell is 0. If n is equal to 2, then value of L will be 0, and now n is equal to 2 means 2 minus 1, that is 1. So possible L values are 0 and 1. So this is also very important. The value of L ranges from 0 to n minus 1. And the subshells are designated as S, P, D and F. If value of L is 0, then it is designated as S. When L is equal to 1, then P. L is equal to 2, then D, small d. L is equal to 3, then F. Now this S stands for sharp lines in line spectra, P stands for principal lines, D stands for diffuse lines, and F stands for fundamental lines. Now energy of subshell within the given shell is in the order S. Subshell has least energy as compared to P, D and F, and energy increases in the order S, P, D and F. F subshell has highest energy within the particular shell. So this is about what is the meaning of azimuthal quantum number. Now consider the K shell. For K shell, value of n is 1, and only one subshell is there, that is 0, and this subshell, it is designated by 1s. This number 1, it is the principal quantum number, and 1s, this is the subshell. Now for L shell, n is equal to 2, two subshells are there, that is 2s and 2p. There are two subshells, 2s and 2p. Now for third shell, n is equal to 3. Possible subshells are 0, 1 and 2, and designations are 3s, 3p, 3d. Similarly for n shell, n is equal to 2, small n is equal to 4. Possible L values are 0, 1, 2, 3, and the designations are 4s, 4p, 4d and 4f. Now S subshell, it is spherically symmetrical, P subshell is dumbbell shape, D subshell is double dumbbell shape, and F subshell is three-dimensional complicated. It has a three-dimensional complicated shape. And the angular momentum of electron, it is related to the azimuthal quantum number, and it is equal to under root L into bracket L plus 1 into h upon 2 pi. H is Planck's constant. So angular momentum of electron, it is determined with the help of azimuthal quantum number, and this is what is azimuthal quantum number. Now next is magnetic quantum number. Now magnetic quantum number, it gives idea about the orbitals present in the subshell. And this quantum number describes the behavior of the electron in the magnetic field, that is the Zeeman effect. So Zeeman effect, it is well described by this magnetic quantum number. It is designated by small m, and the electron, actually the revolving electron possesses angular momentum. It will give rise to a very small magnetic field which interact with external magnetic field and which produces different fine energy levels corresponding to the orientations of orbitals in space. This is what is Zeeman effect. Now m represents orientations of an orbital in space. This m can have values ranging from -L to +L through 0, and for a given value of L there are 2L plus 1 m values. For example, if L is equal to 0, then as per this formula there will be only one m value, that is 0. If L is equal to 1, then possible m values are 3. When we substitute value of L by 1, then 2 plus 1, that is 3, and these 3 values are -1, 0, plus 1. If L is equal to 2, then possible m values are 5, that is -2, -1, 0, plus 1, plus 2. So subshell, that is when value of L is 0, then number of orbitals as per this formula equal to 1, and number of electrons equal to 2. Number of electrons, it is given by 2 into 2L plus 1. Similarly, when L is equal to 1, number of orbitals are 3, electrons are 6. When L is equal to 2, possible orbitals are 5 and number of electrons are 10. If L is equal to 3, orbitals are 7, number of electrons are 14. Similarly, when L is equal to 0, value of m is, possible value of m is only 1, that is 0, and orbital is s. When L is equal to 1, possible m values are 3, that is -1. Already I told you, -1, 0, plus 1, and corresponding orbitals px, py, pz. If L is equal to 2, these are the 5 L values, and possible orbitals are dxy, dyz, dzx, dx square minus y square, and dz square. If L is equal to 3, possible m values are 7, -3 to +3 through 0, and corresponding orbitals are fx cube, fy cube, fz cube, fx into bracket y square minus z square, fy into bracket z square minus x square, fz into bracket x square minus y square, and fx, y, z. These are the f orbitals. And s orbital is non-directional, it is triply degenerate, p orbital is triply degenerate, and d orbital has a 5-fold degenerate symmetry. Now last quantum number, it is the spin quantum number. Spin quantum number, this is very simple. This quantum number describes the spin or orientation of electron, and it can be clockwise or anti-clockwise. S can have two values, +½ it is for clockwise when electrons spin in clockwise, or -½ when electrons spin in anti-clockwise. These are the two possible S values. +½ when electrons spin in clockwise, and -½ when electrons spin in anti-clockwise. Now total spin, it is obtained by formula ½ into m, where n is number of unpaired electrons. So this is about the spin quantum number. So in this way there are 4 quantum numbers. Principal quantum number gives idea about the main energy level. Azimuthal quantum number gives idea about the subshells or electronic cloud present in the given orbit. Magnetic quantum number, it gives idea about the orbitals, and spin quantum number gives idea about the spin of electron, whether it is clockwise or anti-clockwise.